In this lecture, we're going to explore the idea of static binding with inheritance. But before we start, let's look at the inheritance hierarchy we're going to be using throughout this chapter. We will be setting up shape classes, and our base class is going to be a bare shape, and we're going to derive or inherit from this class to create a novel class. And this is going to be representing a shape like this. We can derive from this and also represent a circle class, which is basically going to be a shape like this. All these classes are going to set up a draw member function, which could possibly be used to draw this shape on the screen. If we happen to support this kind of feature in our program, we could do that. So we're going to have a draw method in the base class, we're going to have a draw method in the oval class, and we're going to have a draw method in the circle class. And as we already know, because these methods are completely the same in all these classes, the methods in derived classes are going to hide the methods we have in the base class. So the draw method in the oval class is going to hide the method we had in shape. The draw method in circle is going to hide the draw method we had in the oval class. This is the kind of situation we have here. So this is the inheritance hierarchy we will be using to explore the ideas about polymorphism. And polymorphism, again, is a design principle we had in C++ to manage memory objects through base class pointers. And the basic thing we are after with polymorphism is to be able to go through base pointers or reference and call methods and get the most specific method called on our object. Okay, so if we apply the same idea to our inheritance hierarchy here, we could manage oval and circle objects through shape pointers. Because shape is our base class, so we're going to be using base class pointers to manage real objects in memory in our inheritance hierarchy. For example, we will be setting up oval objects in memory, we will be setting up circle objects in memory, and we will manage them through shape pointers. And if we happen to call the draw method on these shape pointers, we will set up a mechanism that allows us to call the correct methods on the actual object that is managed by the base pointer. I realize this may be confusing to some of you guys, but I will try to make this super clear in this lecture and other following lectures in this chapter. And once you see an example running in Visual Studio Code, you are really going to understand this. But we need to explore these ideas step by step. Okay, I know some of you must be asking, why would I need to manage my objects through base pointer? What is the point of that? Well, suppose you have a painting application like this. This is actually an application we have built in one of our existing courses. And once you are done with this C++ course, you can check that out and be able to build something like this. But the point I want to make here is that if you have an application like this, and you, for example, want to render or draw these shapes on the screen, you don't want to call hundreds of methods to draw hundreds of shapes on the screen. For example, using the knowledge we have today, if we need to draw a circle, we need to draw some kind of draw circle method. If we need to draw the star, we might need to draw some draw star method. If we need to draw some image, we might need to draw our draw image method. But this is not scalable, and this is really not good design if you ask me. It would be desirable to only have a single method that takes a base pointer, and you can really give it any kind of shape to draw, and the C++ program will know which kind of draw method to know based on the kind of object you pass. If you pass in a circle, it is going to draw a circle. If you pass in a star, it is going to draw a star. If you pass in an image, it is going to draw an image. And you will only need to set up one method, which is going to really take into account all these different kinds of objects we have in our program. Again, we're going to make this super clear in a minute, but if you were wondering why we might need polymorphism, or in other words, why would we need to go through base pointers to manage derived objects in our C++ program? Hopefully this is going to give you a clear idea on why we might need to do this. So let's look at our classes that we're going to be using here. We're going to set up a shape class which is going to be representing our shapes. This is going to be our base class. That's the basic use for this here. It has a simple member variable which is going to store the description for our shape. It is also going to have our draw method, which is really not going to draw anything. It is just going to say the description for our shape here. Once we have this shape, we can create other shapes from it. For example, we can create a novel class, which is going to be representing a shape like this. It is going to have two member variables. One is going to be mx radius. The other is going to be my radius. This may represent the radiuses for our oval here. For example, the x radius might be something like this. The y radius might be something like this. And this is how we're going to be representing this shape here. We also have a draw method which is going to print the information about this shape here. It is going to say the description that we're going to be inheriting publicly from shape, but it is also going to say the radius information for this shape. It is going to give us the x radius and the y radius here. And we have a bunch of constructors here. We have a default constructor, which is really not going to do anything. We also have a constructor that is going to be taking two parameters to forward the data in our member variables here. This is the kind of class we're going to set up in our program. We also have another derived class from oval, and this is going to be a circle class. It is going to be a specialization on oval in which both x and y radius are equal. So the x radius is going to be something like this, and the y radius is going to be something like this. And both of these are going to be equal. So this is going to give us a circle shape. We also have a draw method, which is going to print the description and the radius. We can really pick any radius. We can pick the x radius. We can pick the y radius. They are really going to be the same because they are equal for our circle shape. We also have a simple constructor, which is going to take the radius, and we are going to be using this radius to forward the data to our oval part of us. And we're going to be setting this as both x and y radius. This is the setup we have here. Okay, now that we have our inheritance hierarchy, we're going to try and use it and really explore the idea of static binding in C++ inheritance hierarchies. So here we are trying to create simple objects of our classes. We have a shape object, we have an oval object, and we have a circle object. We are going to go through a base pointer and try to manage our objects here. In our first line, we're going to set up a shape pointer, and we're going to store in the address of shape1. And what we would want in our C++ program is that if we call the draw method on this shape pointer, we would want the shape draw method to be called because we have a shape object stored in our base pointer here. Or in other words, we are using a base pointer to manage this object in memory. Down here, we store a novel object in our shape pointer. Or in other words, we're going to be using this base pointer to manage an actual oval object in memory. And the setup we want is that if we call the draw method on this shape pointer now, we are going to get the oval draw method to be called. This is the setup we want. And down here we have another example where we are using this base pointer to manage a circle object. We are going to store the address of the circle object in this base pointer. This is how we do this. And when we call a draw method on this base pointer, we want the circle draw method to be called. So with polymorphism, what we really want is to call a method on the base pointer and get the most specific possible method called on our pointer. This is the setup we want. But this is not what we get by default in C++. If we happen to do this and run our program as is now with the current knowledge that we have, on the first line here, we're going to get the shape draw method called. This is what we want. But on the second example here, we will see that we see the shape draw method also called. And on this line, we will also see that we get the shape draw method to be called. This is not what we want, and this is static binding. So what is happening here is the compiler is looking at the type of the pointer, and it is using that to decide which draw method to call. So the compiler is basically saying I have a shape pointer, so I am going to call the draw method on the shape class. Down here, it is going to see that it also has a shape pointer, and it is going to call the draw method on shape. And down here, it is going to see that it has a shape pointer, and it is going to call the draw method on the shape class. This is what static binding is all about. The compiler is going to resolve the draw method statically. And what that means is that the compiler is going to look at the type of the pointer that we have, and it is going to use that to decide which draw method to call in our inheritance hierarchy. So this is the default, and it is called static binding in C++. We also get the same behavior if we try to use a base reference to manage our actual object in memory. Here we have the same kinds of objects we had in the previous slide, and we are using a base reference to manage our object. And what we really want is that if we go through a base reference to call our draw method, we will get the most specific draw method called. So if our base reference is managing a shape, we will get the shape draw method called. If our base reference is managing an oval object, we want the oval draw method to be called here. And if our base reference is managing a circle object, we want the circle draw method called here. This is what we want. But again, the compiler is just going to look at the type of the reference. So for the first line here, it's going to say I have a shape reference, so I am going to call the shape draw method. That's what we're going to get here. On the second line here, it's going to say, I have a shape reference, so I will call the draw method of the shape class. That's what we're going to see here by default. And on this line here, it is going to say I have a shape reference, so I am going to call the draw method on the shape class. And this is the behavior we get by default. And this is static binding in action. Okay, so now that we have seen what static binding is all about, let's re-examine the idea of why we need polymorphism. And I am going to give you a simple example here. Suppose we have a bunch of shapes we manage in our programs, and we want to draw all these shapes. If we want to draw a circle with the current setup we have, we would set up a draw circle method. If we want to draw an oval, we would need to set up a draw over method, and this will call our circle draw method, and this will call our oval draw method. This is going to do what we want. But try to think about this. If we have 100 shapes in our program, we will need to set up 100 such methods, and this is a mess. I don't think you want to do something like this. And we have another simple case that I want you to consider. Suppose we want to store all these objects in collections, and we're going to use an array to try and drive this point home here. If we want to store these guys in collections, we will need to set up different collections, because as we have it now, we can't store different types in an array. So what we would need to do now is to set up an array for circles, and set up an array for ovals, and do more collections for different kinds of shapes that we support in our program. And if we want to draw them, we have no choice but to set up different kinds of loops. And each of these loops is going to be looping on each of these collections here. Hopefully you can see that this is bad design. We don't want to do this. We want to set up something that is really easier to manage in our program. And polymorphism in C++ was designed to exactly solve this kind of problem. What we really want in our C++ programs is to set up one draw method. For example, we can give it a base pointer, and it doesn't matter which kind of object we pass it when we call this, we will get that method to be called at runtime when we actually need to draw this shape. If we pass in a circle, this is going to draw the draw method on a circle. If we pass in an oval, it will call the draw method on our oval object. If we pass in a rectangle, for example, it is going to call the draw method on our rectangle object. This is what we want. We also want the same kind of setup if, for example, our functions are taking reference, and this is what we're going to get. This is what we want with polymorphism, and this is really going to improve on the design that we had earlier when we needed to set up a specific method for each shape, and we would end up with hundreds of draw methods, and that's really bad. It's not manageable. This is also going to solve our problem with collections. We really need to set up one collection which is going to be taking into account all the shapes that we manage in our inheritance hierarchy. So the setup we do is something like this. We're going to set up an array that is going to be storing pointers to shape, and we can store in the address of a shape, we can store in the address of an oval, we can store in the address of a circle, because if you really think about it, a circle is a shape, an oval is a shape, and a shape is a shape. So this is going to work. And when we get to loop through this collection and call the draw method, for the first item here, we will call the draw method on the shape. For the second element here, we will call the draw method on the oval object. And for the third element here, we will call the draw method on our circle object. And we will draw a shape, an oval, and a circle with just one loop. And this is really cool. This is the design we want. Now, this is not the default behavior we get in our C++ classes if we set up an inheritance hierarchy with our draw methods. What we get by default is static binding, but we will see how we can get dynamic binding or polymorphism in the next lecture. For this one, we're going to explore static binding, and we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is static binding with inheritance. We are going to grab our template files. This is going to be our starting point here. We're going to put in these files. And I am going to put in our classes to save time. If you want, you can download these classes from the attached resource section on this lecture. You're going to find them and you can use them as a starting point. This is going to save us a few seconds because we don't really want to type these classes. You already know how to create classes if you made it this far in the course. So I am going to drag this and drop here to open in Visual Studio Code. And this is going to give us a good starting point here. We have a base class, which is our shape class. It is going to have a simple member variable, which is going to be the description. One thing I think we need to improve on this is to use a string view to pass our parameter here. So let's include string view. We can include that here. We're going to say include string view because we are using modern C++, and we're going to change this to be an std string view by value. We can do this. Okay, so we have our class here and we have a draw method, which is really not going to do anything special. It's going to just print the description here, and we're going to see it printed out on the output stream. If we look at the CPP file, we just have an implementation of our constructor and we have a destructor. We're going to fix our parameter here to make it an std string view. Let's look at our oval class. It is going to be deriving publicly from shape. And we have a bunch of member variables here, two to be exact. One is going to be the x radius. The other is going to be our y radius. We have a constructor here, which is going to be taking three parameters, two parameters for the data for our radius here. And we have a third parameter, which is going to store our description data. We're going to also change this to be std string view. And this is going to do, we have a draw method, which is going to be printing the description and our radius data. And this is really it. We don't need anything fancy here. Let's look at our oval CPP file. It is going to have the implementation for our constructor and our destructor here. We just need to change the type for our description here and make this an std string view. Let's do this. And we will look at our circle class, which is going to be inheriting from oval. Publicly, it won't have any member variable because it's just going to forward the data to the oval part of ours. It doesn't really need to do any other specialization. But what we need is a method which is going to return the radius because we want to print that here. So we can head over in our oval class and set up a protected section, which is going to give us these methods here. So I am just going to put them in here to save on some time. It is protected because we want this to be usable in derived classes, but we don't want this usable from the outside. This is the setup we can achieve by making these guys protected here. GetXrad is going to return the X radius. GetYrad is going to return the Y radius. They are a const because we don't intend for this to modify our object. And if we go in our circle class, this is going to work now. We will be able to print our information on our circle object, and we will see on our output stream. If we look at the implementation of our circle class, it is nothing complicated. It is just going to take the double radius and it is going to forward the data to the oval part of us. And our description here will need to change to take into account that we want to use std string view here. So let's change this to be std string view. We can do that. And we are going to head over in our CPP file and change that as well. std string view, we can do that. And now our classes are really complete. We can head over in our main CPP file. We can clean that up a little bit. And we're going to remove what we don't need here. We are going to include our classes. So we're going to include shape. Let's do that. We are going to put in oval. Let's do that. Oval.h. And we are going to put in circle, and we are going to create objects of these classes and try to print their information. So we're going to set up a shape called shape1. We're going to set up an oval called oval1. We're going to set up a circle called circle1, and we're going to see what kind of information we see if we try to call the draw method. Again, in shape, the draw method is just going to say that we are calling shape draw. In oval, we are going to say that we are drawing an oval, and we're going to say the description and the radius. In circle, we're going to say that we are calling the draw method on a circle object and say the description and the radius here. This is the information we want. So we are going to try and build this program using GCC, our favorite compiler. You can really use any compiler you have your hands on, but we are going to use GCC here because it is our favorite, and we're going to have a bunch of errors. What it is that we have here? What is it that we have here? Let's go in shape header at line 4 and see what we have. And we have a J here that we don't want. Let's take this out, and we're going to build again. We're going to pass this through GCC. And the build is going to be good. We can bring up a PowerShell window to run our program. Let's run Rooster. And we're going to see that shape draw was called drawing shape 1. You see, we have just created shape 1 here, and we are printing its information. We are going to call the oval draw method, and we're going to print the information on that. You see that it is oval1 here, and we're going to put out our radius data. X radius is going to be 2 as we specified here. Y radius is going to be 3.5, and this is our information. We are also going to call the draw method on our circle object. This is what we get. And we're going to say we are drawing circle 1, and the radius is going to be 3. This is our information here. But we don't want to go through direct objects to manage our data here. What we want is to either go through base pointers or base references. So we are going to set up a shape pointer. Let's do that. We're going to say shape because that's our base class. And we're going to say shape ptr to represent our pointer. And we're going to store in the address of shape1. We can do something like this. And to really see what is happening, we're going to comment out our calls to draw method here. And we're going to see what happens. So if we say shape ptr and call the draw method, we can do that. Let's try and build our program. We're going to pass this through GCC. You're going to see that it is going to work, and it is going to do what we expect if we run this program here. You can clear and run Rooster. We're going to see that shape draw was called, and we are going to be drawing shape 1 here. This is what we expect. But if we go down and say we don't want to call the draw method here, we are going to store in, let's say shape ptr, and we're going to store in the address of our oval1 object. And we want to call the draw method here. Now, if you do this, as we saw in the slides, what we really want is to get the draw method on our actual oval object called. And if we were, for example, drawing things on the screen, we would draw an oval. This is what we want here. But this is not what we're going to get. You're going to see that we still get the draw method from the shape class called, and it is going to say drawing oval1. Let's try and build this program, and I really want you to see this. So the build is good. We can clear and run Rooster. You're going to see shape draw, even if we are storing again a novel object. So this is the default behavior we get, and this is static binding that we get by default in our inheritance hierarchies. So what the compiler is really going to do here, it's going to look at the type of the pointer that we have here. It is going to say, I have a shape pointer, so I am going to call the draw method on the shape type that I have in my pointer here. And we are going to see that this is calling the draw method on our shape. And this is not what we want in most cases. We are going to see that we get the same behavior if we store a circle object. Let's do that. We're going to say shape pointer, and we're going to store in the address of our circle one. And then we're going to call our draw method on our shape pointer. Again, this is going to draw a shape. It's not going to draw a circle that we really are managing with our base pointer here. And some of you must be thinking, why are we able to store circle pointers, for example, in a shape? Well, a circle is a shape according to our inheritance hierarchy. If we take a closer look again here, you're going to see that oval is going to be inheriting from shape, and a circle is going to be inheriting from oval. So from what we learned in the last chapter, oval has a shape part in it, and circle has an oval part in it, which in turn is going to have a shape part in it. So from this understanding, it shouldn't really be surprising that we are able to manage a novel object with a shape pointer, or the fact that we are able to manage a circle object using a shape pointer. This is why we are able to do something like this. Okay, so I hope this is super clear. But again, we are not getting the default behavior that we want, but we will see how we can achieve that in the next lecture. For now, I really want you to understand what static binding is all about. And it is the fact that the compiler is going to look at the type of the pointer here and use that to decide which method it is going to be calling in our inheritance hierarchy. The compiler, for example, is going to see that we have a circle object stored n at line 25 here, but when it wants to decide which draw version to call, it is going to look at the type of this pointer here, and it is going to use that to decide which draw method to call. And in this case, it is going to call the shape version because the type of this pointer is shape. Okay, so I really hope this is super clear here. We are going to get the same behavior if we try to manage our objects using references. For example, if we go through a shape reference, let's do that. We're going to say shape reference and say shape ref. And we are going to store in shape one, for example. Let's do that. And we want to call the draw method on shape reference. Let's do that. So let's call the draw method. And you're going to see that we will get the shape method called. And this is really making sense because we have a shape object managed by this reference here. So if we build our program, let's do that. We're going to pass this through GCC. You're going to see that we get what we expect. The build is going to be good. We're going to clear and run Rooster, and we see shape draw called. This is what we want. But if we use this reference to manage a derived object, for example, let's put in oval1, we can do that. We're going to see that we don't get the most specific draw method for oval here called. We will still get the method for shape called. Let's build and show you this. This is static binding again. Okay, the build is good. We can clear and run Rooster. We're going to see that shape draw, it is drawing. We don't get the oval draw method called. We get shape draw method. Again, the compiler is going to look at the type of this reference by default, and it is going to use that to decide which draw method to call. If we even put in a circle, we are going to get the same behavior. Let's build with GCC. The build is good. We can clear and run Rooster. We see that shape draw is called, and this is really not what we want. Okay, so this is static binding, and it is the default behavior we get if we have an inheritance hierarchy with the same method spread across each derived class, we're going to get the shape version called, even if what we are really managing with a shape pointer or a shape reference is a derived object. I really want you to understand this. Now, let's see why this is really bad design by default in C++. If we happen to need to pass shape parameters to functions, for example, we might do something like this. We might need a function to draw a circle. We might need a function to draw an oval. And if you happen to have 100 objects you can draw in your program, you have no choice but to set up 100 drawing methods or functions. This is really bad design. You don't want to do something like this. So what you would do in your program, for example, is go down and say drawing. And you would say, for example, draw circle and pass in a circle and say draw oval. Do we have a draw oval function? Let's see. Yes, we have that. We can go down and say draw oval and pass in our oval one. This is going to work just fine, but hopefully you can see that this is bad design. If you have a lot of shapes in your program, this is going to quickly become unmanageable and you don't want to do something like this. What we want is to be able to only have one method and get the C++ runtime to resolve which one is called at runtime when we get to pass our actual objects, and we will only have one function which is going to take into account hundreds of shapes that we might potentially have in our C++ program. This is going to be much easier to manage, and we will actually be able to achieve this in the next lecture, so stay tuned for that. Another problem with this is if you happen to need to store these shapes in collections. If you need to set up something like this, you will have no choice but to set up different collections for each type. For example, we might set up a collection for circle, a collection for oval, and here we are just using arrays to model our collections. And this is really bad design. If you happen to have 100 shapes in your program, you will set up 100 such collections. And the only difference is that they are just different types. And this is really bad design because even if they are different types, they are related and they are all shapes in our C++ program. And what we really want is to set up one collection which is going to take into account all these kinds of shapes that we might have in our C++ program. And we will be able to achieve this again in the next lecture. But the whole point of this lecture was to show you static binding that we get by default with our inheritance hierarchies. Static binding may be bad if you really are managing a lot of related objects in your C++ program. And all these objects have the same method that each derived class is specializing, but you want the most specialized method to be called on the actual object that you are managing with a base pointer or a base reference. Hopefully this is super clear. I apologize this lecture turned out to be really long, but I wanted you to make this super clear, and everything else we do in the remainder of this chapter is really going to fall in place. So make sure you understand this, and if you have a problem, do ask me. I will do the best I can to help you out. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to show you how you can achieve dynamic binding using virtual functions in C++. Go ahead and finish up here and meet me there.